Okay, so let's see what MMC and LMC mean. MMC stands for maximum material condition and LMC stands for least material condition. MMC and LMC are features of size symbols, which means they can be applied to features of size. These can be planar features of size, cylindrical ones, or spherical ones. In this video, I'll teach you MMC and LMC using cylindrical features, but just know that the exact same concept applies to the other ones. It's very easy, I promise. So, let's look at this simple cylinder. As you know, the diameter size dimension here is specifying a feature of size. Here we have 50 millimeters plus and minus 1 millimeter. This is a size tolerance of 2 millimeters. The MMC or maximum material condition is basically the state that your feature has its maximum amount of material. So for this cylinder, our MMC is 50 millimeters plus 1 millimeter, giving us 51 millimeter, simply because this will be the maximum amount of material you're allowed to have. Now, as you've probably guessed, LMC is the exact opposite. It is the state that your feature has its least amount of material. So in the same example, our LMC is 49 millimeters because it gives us the least possible amount of matter. Easy, right? This is our cylinder in 3 levels. In the bottom, I have its MMC, and on top, I have its LMC, and in the middle, I have my nominal 50 millimeter size. Let me also emphasize that I have used symmetry tolerance, and that is the only reason my nominal size is in the middle. It is definitely not a necessity, so keep that in mind. Now, let's make it a bit more interesting. Let's see what happens when we deal with a cylindrical hole. This again is a feature of size. Remember that features of size can be external or internal. In this case, MMC and LMC work in the exact opposite way. This is because you get more material when a hole gets smaller. You also get less material as the hole gets bigger, right? This is why if we have a diameter size dimension of 60 millimeter plus and minus 1 millimeter, our MMC will be 59 millimeter and our LMC will be 61 millimeter. This is simply common sense and there's nothing complicated about it. Now, let's also look at our part in all 3 states. We have our MMC in the bottom, our LMC on top, and our nominal value in the middle. Just remember that boss and hole features get to MMC and LMC the exact opposite way due to their nature. Boss features have material and hole features have absence of material. Easy, right? Now, let's approach this in a more interesting way. Let's look at these 2 parts here. What I have is a cross-section of a cylindrical boss and hole feature next to each other. I have cut them from the center so you visualize them better. Now, what do they present? Well, we have all the size possibilities of our boss and hole features in an exaggerated way. Their sizes change as you move in the z-axis. As we covered, for a boss feature, MMC is the largest size, and for a hole feature, MMC is the smallest size. So we have MMC of both parts on the bottom. We have the same analogy, LMC for both parts is on top. This is our boss's smallest size and our hole's largest size. If you use symmetry tolerances, the middle will be your nominal size, but again, this is not always the case. Nominal size can be anywhere on the part or even outside the range in certain cases. Now, let me show you something about MMC that makes it brilliant. Think about a case where you want to assemble your boss into the hole. Now, I want you to think about a case where you would have the tightest fit, which is in fact the worst case in assembly. Maximum material condition for both features will give us the worst possible case when dealing with assemblies. So if our 2 parts fit when they are both at their MMC, we will know that they will definitely fit in all other cases. This is brilliant and there are so many things we can do with it. But let's not get carried away. LMC also has its specific uses which you will fully learn in later videos. Right now just focus on the definitions for MMC and LMC. I will teach you everything about them later. Sounds good? Great. I'll see you in the next video. For those of you serious learners, I have a full professional course on GD&T that covers all aspects of GD&T with many examples, quizzes, and state-of-the-art graphics that make learning this complicated subject a breeze. So check it out if you're interested. I hope you learned a thing or two from this video today, and I hope to see you again soon. Have a great rest of the day.